Hi, in this video we are going to implement the Ford Fulkerson.java class. So first we have to create a private boolean array, basically a one-dimensional array with the marked variable name. Basically I'm just going to make some comment. So if the marked for the v vertex is equal to true, it means that there is a path from the source to this given v vertex. Okay, so if this marked on the v vertex, why is it v vertex? Because we assigned an ID to each and every single vertex, so we are able to put some get ID or something like this. So if this marked, so this boolean array contains a true for a given vertex, it means that there is a valid path from source to this given v vertex in the residual graph. Okay, it's very important. Then we are going to store in a one-dimensional array edges, for example, edge 2. Basically, this one-dimensional edge array is going to contain edges, so edge 2, a given v vertex, is going to be equal to the last edge on shortest path in the residual graph. So basically we are going to collect all the edges that the given shortest path, so basically this edge one-dimensional array is going to contain the augmenting path. Okay, so it is the edges in the augmenting path. And basically we have to store a reference to a private double for the value of the maximum flow. It's going to be the maximum flow. And we will have the public Ford Fulkerson, basically. It's going to be the constructor. It's going to get a flow network. So flow network with the vertex source and the vertex t, which is the thing. And I don't want to do it in the constructor, but now, just for demonstration purposes, we are going to do it. So what is the Ford Fulkerson algorithm? That while we has an augmenting path, so while there is an augmenting path in the flow network with the S source and the T target, then we have to iterate, and basically we have to calculate the bottleneck. So it's going to be the bottle, which is going to be initialized as the double dot positive infinity. Okay, because we have been talking about that what do we have to do? The Ford Fulkerson algorithm is to calculate the residual network and basically find the shortest path possible in the residual network. Okay, basically we just have to get this path. These edges are going to be pushed and stored in the edge one-dimensional array. And basically this bottleneck, what is this bottleneck? We have been talking about that, okay, we come to the conclusion that this is the augmenting path, 5 and 1. And we have to calculate the minimum out of these values. Why? Because we are not able to choose the value 5, because here the capacity is 1, so we are not able to flow 5 units where the capacity is equal to 1. So we have to calculate the minimum value out of these edge weights. And this is why we create this bottle, basically. And we have to iterate through the vertices from the source. So in a reverse order, basically, the v is not equal to the source and the v is equal to the edge 2, because we store the augmenting path edges in this edge one-dimensional array. And we just have to get it according to the IDs. So get ID dot get other, because we keep going and backtracking basically of this v. Okay, and then we have to calculate the minimum. So the bottle is equal to the math dot min on this bottle, sorry for that bottle, and the h to the v dot get id that get, very important that we have to get the residual capacity on the V. Okay, because as you may recall, we have to do this calculation on the residual network. So this is why we have these edge weights in the residual graph. So we have to calculate the residual capacity. Sorry, this residual capacity is not a good name, by the way, because as you can see, we return the flows. But somehow in scientific articles, they usually call it capacity. But as you can see, it is not a capacity, it is a flow as far as the backward edge is concerned, and the capacity minus the flow as far as the forward edge is concerned. Okay, so that's all about getting the minimum, basically finding the augmenting path. And then what do we have to do? We have this bottleneck, and we just have to add it in the original graph, so in the flow network. So we just have to iterate through in the vertex V is equal to the T. In a backward manner, V is not equal to the S. V is equal to the H2. So again, we have to consider these edges, but not in the residual network, but in the original network. So the V.getID and get other for the V. Okay, and we just have to make the H2 on the V.getID, and we have to add the residual flow to the given V, and the delta flow is going to be equal to the bottle. That's why we have calculated it. Okay, maybe I'm going to manage to write it down. Okay, so we have the vertex, which is the V, and the bottleneck, basically. Or I'm going to rename it just to be clear. It is the minimum value. Or minimum, okay, minimum value, whatever, it's going to be fine. I'm just going to save it. And basically that's it. After all, we just have to increment the value flow. So value max flow is equal to the value max flow plus the mean value, so the bottleneck. Okay, so what is this? Basically, that's all about the Ford Fulkerson algorithm. While we have an augmenting path, we consider the shortest path, so get an augmenting path. We get the minimum value, as we have discussed in the theoretical section, and we keep odd residual flow in the original network. So this odd residual flow is going to get a vertex and a delta flow, and it's going to subtract this delta flow in the backward edge and add it in the forward edge. Basically, we don't want to create a distinct residual graph. That's why we calculate something like this. Okay, so in the next video, we are going to implement the augmenting path with the help of breadth first search. Thanks for watching.